This is page 9 in our notes. I'm using purple and black for my colors today. This is standard NS.4 on greatest common factors. GCF is how I'm going to abbreviate it. Some of you have learned this before, and before we get into greatest common factor, we need to talk about common factors. So common factors are going to basically just be factors that two or more numbers have in common. Factors that two or more numbers have in common. I'll give you an example of that that'll make that better for you. But if I say, like, what are the factors that 12 and 24 have in common? The only way I know how to do this is the old list method. So whenever they ask for all of the common factors, you have to list all of the factors out for 12, and then you're going to have to list all the factors out for 24, and then just circle which ones they have in common. So 12 and 24, you would just need to list their factors out. And you remember, factors are numbers you multiply to get 12. So like 1 times 12, 2 times 6, and 3 times 4 are all the numbers you multiply to get 12. What numbers can you multiply to get 24? So what would 24's factors be? 1 and 24. Notice I'm giving a little bit of room to write. 2 and times 12, and I got 1, 2, so the next one would be 3 times 8 gives you 24. 4 times 6 gives you 24, and the only number between 4 and 6 is 5, and that does not go into 24. So what factors do they all have in common? They have a 1, 2, 3, 4, 6, and 12 that they have in common. So their common factors of 12 and 24 are the ones we circled, and you would just have to write all those out. 1, 2, 3, 4, 6, and 12. So whenever they ask for common factors of everything, you have to list them out. Unfortunately, I don't know another way for common factors. The actual standard NS4, they're just going to be asking us about greatest common factors. So that's kind of nice, because greatest is just talking about, of all the common factors, which one's the greatest. So the greatest common factors, I'm going to abbreviate with GCF, is really just the biggest of all the common factors. So you could say it is the biggest of the common factors. So as you look up there in that example, we had a bunch of them in common, but the greatest one they had was 12. So that's what this standard is about, greatest common factor. What's cool about the greatest common factor is there's a neat method we could use without having to list. GCF of 12 and 24 is blank. What did we say the greatest one was between them? It was 12. And what's cool about GCF, since that's our standard, we have something really cool to show you. I'm going to put a star here. We're going to use the ladder method whenever we're talking about GCF, greatest common factor. I actually showed you the ladder method before. We had done that with prime factoring. So let's practice it. We already kind of know the answer, but let's go. What is the GCF of 12 and 24? So how this works with the ladder method is we have to put 12 and 24, and we have to make a rung on the ladder. And when we made a rung, we were looking for a prime number that goes into both of them. Prime meaning that it had exactly two factors. So prime would be like 2, 3, 5. They were your smaller numbers. If you put a 2 over here, 12 divided by 2 is 6, and 14 divided by 2 is 7. Oops, I just realized I did the wrong number. This isn't 14. This is supposed to be 24. Well, no wonder that looked so weird. All right, cross that one off. Sorry about that. I'm looking at 12 and 24. Sorry, did this video once and had to do it again. 12 and 24. Let's try that again. My fault. 12, looking for a number that goes into them. 2 would also go into them, but I'd like to use 3 for my example. 3 also goes into both. 12 divided by 3 gives us 4. 24 divided by 3 gives us 8. Do I make another rung? Do I have another number that goes into both of those? Yeah, 2. 2 is a prime number that goes into both. Don't put a 4 out here because 4 is not prime. It's a composite number. So 4 divided by 2 is 2, and 8 divided by 2 is 4. Do I make another rung on the ladder? Is there another number that's prime that goes into both 2 and 4? You should see it. It should be 2. So make another rung. And you're going to divide each one by 2. And that would give you 1, and this would give you 2. And you can't make another rung because 1 is as small as you can get. You can't divide and make it any smaller. So when you're trying to find GCF, you just circle all the numbers on the outside and you multiply them all by each other. So remember, the numbers that we're putting out here on the outside have to be prime numbers. So you have to, I'm sorry about this example here, you basically have to circle the numbers on the side and multiply to find the GCF. And in this case, our GCF, 3 times 2 would give us 6, and 6 times that 2 would give us 12. So our GCF is 12. And we actually already knew the answer was 12 because we had done it up above the whole listing and then having to circle the biggest one. But I would like you to use the ladder method anytime they ask for a greatest common factor. And I apologize for the error in my notes there. So we're going to draw a line. And we're going to do a couple more examples to practice GCF. The next example is the greatest common factor of, we're going to go 45, 75. So I've already set it up so that we could make a rung on the ladder here because I know a number that's prime that goes into both of those. They both get to 5, so I could divide both by 5. 45 divided by 5 is 9. I know my facts, that helps. If I don't know how many times 5 goes into 75, you may have to divide to the side here. Let's see, 1 times I get 5, 2, bring down the 5. 5 would go into 25. 5 times I get 25, subtract. So it was 15. So 5 times the 15 would have given us 75. Can we make a rung on the ladder here? Is there a prime number that goes into both 9 and 15? You should make a rung. The number is 3. 3, so 9 divided by 3 is 3 right below it. 15 divided by 3 is 5 right below it. Both of these are prime, so like 1 and 3 are the only thing that go into 3, and neither one of those, if you write it on the outside, is going to make 5 any smaller. So you're done. GCF. What do I do with GCF? You circle numbers on the side and you multiply them. So the GCF is 15. Your GCF equals 15. So 15 is the greatest common factor of 45 and 75. Draw a line here, do another example to the side. What is the GCF of 20, 32? And I will make a rung on the ladder because I see a prime number that goes into both of those. And that prime number could be 2. 20 divided by 2 is 10, and 32 divided by 2 is 16. So greatest common factor of 20 and 32. Do I make another rung? Is there another number that goes into 10 and 16? That would be a prime factor of both. Yep, another 2. 10 divided by 2 is 5, and 16 divided by 2 is 8. 5's prime. The only numbers that go into it's 1 and 5. And if you try to divide 8 by 1 or 5, is it going to make it any smaller? Nope. So you are done. Remember, you circle the numbers on the side and you multiply them. Don't add them, you multiply them. And your GCF is 4. I guess in this example, if you accidentally added them, you would still get 4. But you're just supposed to multiply the side to get greatest common factor. That's why I like the ladder method. I feel like it's easier, it's neat, it's kind of cool, and it's also going to lead right into least common multiple. So your homework that you need to do is a worksheet, 1.3. You need to do numbers 1 through 8 all. So problems 1, 2, 3, 4, 5, 6, 7, 8. Some of them are going to ask you to list all common factors. So you need to use the list method. And then some are going to ask for greatest common factor, and I want you to use the ladder method.